Okay, here we are again. Favorite time of the month. I can't believe that I have it this early because usually I have to wait until like middle of the month in order to get this thing. But let's see what our friends at Hackerboxes have in store for us now. A soldering iron, a wrench, and a gear. Huh, it's a nice chain. Ooh, some solid state relays. That's good. Some jumpers, banana plug jumpers. A switch, a pot. What are we building this time? USB extender cable, a battery pack, a voltmeter or ammeter. One of the two. Probably a voltmeter, but who knows? Ooh, another ESP. I wonder if this is an ESP32 or if this is an ESP, regular ESP. What do we have here? Please peel off this mask after application. I'll dig into that later. Oh, a bunch of power resistors and some binding posts. I wonder what we're doing. USB to a battery charger. Yeah, that's a battery charging module right there. Out. B plus, B minus. Oh, an LM. That's. I'm gonna have to look at see what that is. This is either a boost buck or a constant current. Probably a constant current output. Some feet. A USB to UART. Some shrinking tubing. And so, what is this guy actually? Let's get some light on it. No, it's an 8266. Okay, so we've played with those before. But Wi-Fi module, the standard thing. Now, what's in this little package here? Okay. Oh, this must be the LiPo. This is a battery. A 20,000 milliamp, a 20 amp hour battery. We'll just see about that. All right, I looked at that. Some jumpers, some more. Oh. Some swag, look at that. 6-in-1 keychain. Swiss Tech, screwdriver, bottle opener, gotta like that. Scissors, serrated knife blade, straight knife blade, solid stainless steel. I wonder what you're supposed to do with that. But it's a cool thing. Oh yeah. Elite Maker Bench Supply. Well, what do you know? Okay, so boost buck converter, a lithium battery charger, and a USB supply. So something tells me what we're going to do is we're going to make a bench supply that, what the heck does it have the Wi-Fi for? A Wi-Fi enabled bench supply? And what do we have here? That's probably a 5-volt regulator or a 3.3 volt regulator in here. What is this little SMD mount, baby? Yeah, LM 1117 3.3 volt regulator. Okay, so I wonder what they're going to have us building. Okay, so if you haven't hacked up a USB cable to give yourself a alligator clip output from and to a USB jack, so that you can clip plus and minus to a battery or to a circuit, and then plug this into a USB port and grab the 5 volts off of it, 300 milliamps for USB maximum. Then they give you some stuff to make such a thing. So that's what this is for. A little bit of heat shrink tubing in order to neaten up your solder connections. And, well, that's nice. All right, yes, this thing is a power tester, a load tester. It tests how much current is being drawn through USB connections. So either this side or this side goes in, or either this or you plug into there to whatever your power source is. So let's plug it into this battery. And then you plug the device that you want to test into this little guy, and then it will, once I turn it on, it will report back what current is being drawn and at what voltage. So this, my phone is drawing 5.1, 5.808 volts at about 400 milliamps, 0.4 amps. Okay, yeah, so if I plug it into a legit outlet, it's much more stable. And then maybe we can figure out what this button does. Maybe it's a hold button, I don't know. I'll Google it. Oh, maybe you can measure, because this is reporting things in milliamp hours. Maybe between button presses it will tell you how many milliamp hours, so you can test like battery capacity and things like that. Anyways, oh wait, oh look, instructions. Hold the button until it shows the first saved data. Release the button. The data has been cleared automatically to skip to the next one. Data checking mode. Yeah, exactly. So you can do some battery capacity measurements using that thing. Nice. Okay, on to the next little bit of goodness in here. Well, there's two things. This I recognize as a LiPo battery charger. These things actually buy these by the meter. The boards come, well, whatever the width of FR4 is, you know, like they're literally a quarter a piece, if that, if you're not even trying hard. So, but it allows you to take a micro USB and charge up your LiPo battery. So you put the battery on here and then the battery out. And so when you plug this in, it starts charging the LiPo. It'll also do the balancing for, or it'll ramp down the current as it gets close to full charge, and it does all the nice things that it needs to do in order to charge up single cell LiPo batteries, or LiPo, or lithium polymer, whatever, however you want to call them. But this little guy, this is a boost converter. So what it will do is it will take what any voltage below 5 volts, and it'll boost it up to 5 volts. So if by some chance you have a box full of things like 18650 cells that you've pulled out of laptop batteries, and you want a way of charging them, and you don't have one of these chargers, you can make a little battery holder out of some PVC piping, just plumbing pipe, or you can buy these little 18650 holders on Fleabay and use those, and you can turn this into a nice little battery charger for your 18650s. Not only that, but apparently, as we've seen, we can use this little guy to determine what the actual capacity of those batteries is by hooking them up to this, and then measuring how long it takes for that battery under load to deplete, and it'll tell us how many milliamp hours were delivered through that battery. So now we can test 18650 cells or any other kind of lithium. Oh, this one's kind of feeling a little puffy. I should probably get rid of that one. But these two are probably all right. So yeah, you can put a battery charger onto these as long as they're a single cell LiPo, and you can tell that by how many terminals are on here. You know, this is actually looking a little dangerous. I'm going to probably have to take that outside. And Yeah, and so you can create a charger that will allow you to charge up any kind of LiPo, and then you can also use this little guy to determine how much juice they have and if they're actually good. Yeah, cool. All right, yes. Now this collection of goodies is indeed for converting a bench supply, an ATX power supply, into a a bench supply. Sorry, an ATX power supply into a bench supply, with the option of adding a variable voltage output. So this is a boost buck converter. It doesn't do constant current. It only does variable voltage, either boosting or bucking. Now, a couple of things about this guy. You will not be able to get your voltage down to zero. There is a minimum voltage, 1.2 volts, but if you have a 35 volts in, I think there's a couple of 1.2 volt drop, and so you'll get 34.8 out roughly. But in your standard ATX power supply, you only have a plus 12, plus 3.3, plus 5, and sometimes a negative 12 rail. So using your 12 volt rail, you can get between 1.2 and something close to 11 volt variable output. And then up to the maximum current that this guy is able to provide, and the maximum current that your power supply is able to provide, minus the losses that you're going to be getting out of this for boosting that 12 volts up if it's above 12, or current losses that you're going to be power losses that you're going to be getting as you're burning off voltage if your output voltage is much different from your input voltage. So anytime you've got a difference between your input voltage and your output voltage, you're going to have some power being consumed by this device as it burns off or boosts up those voltages. So yeah, there's lots of instructions on Instructables. I've made a couple of these power supplies myself. They're not too terribly difficult. It's mostly an exercise in mechanical engineering and trying to fit all of the different things that you want to fit onto your ATX power supply case onto what you're doing. These power resistors are there because, like I said earlier, the ATX power supply, some of them need to have some load on the 5 volt rail or else the regulation won't work. One of the other things that you need to keep in mind is that there is a sense wire that needs to be grounded in order to turn the power supply on. So you'll have a switch that is on-off that will ground out one of the sense wire on the power supply, and then you'll have an on-off switch will actually turn on the power that's coming into the supply or out of the supply. So yeah, lots of stuff on the Instructables website that can get you going with making a nice little bench supply, and they come in darn handy, especially when you've got a nice little boost buck converter that gives you a variable output. Now, all you're going to be doing with this is there's a pot in here. So this trimmer pot is a 103, so that's a 100 ohm, 103, 1030, 10K pot. Yeah, be 10K. So there's a 10K pot that you need to remove this from the board, desolder it there, and then it doesn't matter which way it goes. If turning it one way makes the voltage go low and you want it to be going the other way, just reverse the outside two wires and you'll have the pot going in the correct direction. But yeah, that is that's a nice little collection of kit in order to make yourself a nice little bench power supply. And then finally, turning our attention to this guy, what they're in, well, actually a few things. They provide you with a ESP 2866. They provide you with a TTL converter. That didn't work, did it? Another USB to TTL converter. Now, if you take a look at these guys, they have, let's zoom in there a bit. They do have a 3 volt output, but the amount of current that this 3.3 is able to provide is minuscule. It's not really very much, but you've got access to your full 5 volts, 300 milliamps coming off of, well, and if you've got it plugged into a high power USB, you can get, I think, up to an amp on USB. I'm USB 2. I'm not 100% sure. Would have to check that. But anyways, much more than the current that's available here. So what they provide you is a surface mount LM1117. Sorry. Surface mount LM1117. This guy will be able to handle, I think, something like 3 amps. So more than enough to deal with USB levels of power. And so you can tap off of the 5 volt rail here, which I think it appears here. And then you've got a 3.3 with enough current to drive this thing, the ESP8266. Now, this guy needs actually a fair amount of current in order to be to drive the radio. Radios require a lot of current, up to an amp, I think. So you probably need to get an amp off of here, off of your USB, in order to power this. So it does need a fair amount of power. But now you've got a USB programmable ESP8266 that you can probably even, now you don't have to use this as the programmer. You can just plug it into power. And now you've got an Wi-Fi enabled, if you way of controlling line current, because these guys are solid state relays. So they take 10 amps at 250 volts or 10 amps at 30 volts DC. Well, 10 amps everywhere, it looks like. 28 volt, 125, 250. And so you've got 2 circuits here. Not exactly the most beautifully built board. Somebody could have spent more time getting that lined up. But in any event, these 2 guys here are opto-isolators. So what you've got here is a ground, in 1, in 2, and VCC. So on this side of the board, we've got, now let's see, how safe is, there's no cutouts. That should provide some more measure of isolation. So I'd be very careful using these with line voltage, but as I was saying, you have voltage levels and current levels coming off of digital pins on some microcontroller. In this case, they've given us an ESP8266 in order to use. These are opto-isolators, and what they'll do is they isolate these electrical signals from these electrical signals. So there will be some noise in these relays, and these opto-isolators will prevent you from picking up that noise on your ESP8266 and causing havoc with your microcontroller. On this side of the board, what we've got is line level switches. Not line level. Mains voltage level switching. So a signal here will cause this relay to close, which will allow you to switch your mains level. So you can turn on and off all kinds of things. As long as it draws less than 10 amps, these will be able to turn them on and off. So lights, pumps, Halloween displays, Christmas displays, little motors, all kinds of things could be turned on and off using a Wi-Fi enabled jobby like this. So this thing can I don't know if I've gone into what you can do with these, but these are an amazing little device, ESP8266. They're the predecessor to the ESP32 that we got a couple of months ago. So it's a Wi-Fi chip that can be a Wi-Fi server. It can be a Wi-Fi client. You can program these using an Arduino IDE. You can make them a little web page so that you just hit the web server, and you can write a little UI for it inside of a web browser, so you can basically web control anything that you can plug into the wall now. So that is what this little collection of doodads allows us to do. And I do have some ideas on what I want to build using these relays. I mean, at the very minimum, you can turn lights on and off with a web browser now, where you don't even have to have an access point, because this thing is an access point. But no plans in the immediate future to build something with that, but definitely it's on the list of things that I'm going to get around to. And yeah, nice little collection of goodies from our friends at Hackerbox. All kinds of little projecty doodaddies that will come in handy if you're doing any kind of experimentation in this area. Not quite the really cool, exciting sending a text message with a cell phone by building a cell phone, but still a very useful little box of gadgets. Thanks again, folks at Hackerbox. You have brought some fun to my life, and thanks for doing the stuff you do. Bye for now.